Hi everybody, this is Mrs. John once again solving problems for year 11 mechanics, and this is another question on energy. Now this one has to do with energy transformtransformation, and this is question 5. It's a slightly long question, so I'm just going to take you through the steps. So a child throws a 0.100 kilogram ball as hard as she can towards the ground, and she initially throws it from here, but then because she throws it with an initial speed, it bounces up above her head. So the initial height was 1 meter, but then after it falls down, it bounces to a bigger height. So what actually happens if you have a ball and you just let it go, the initial speed is 0, and it's either, if no energy is lost, it's going to bounce back to the same height that you threw it from, or if it loses some energy as heat and sound, it's not going to bounce back as high, it'll bounce lower. Now this question's a bit different. Now this ball doesn't have an initial 0 velocity because there's an initial velocity of 4 meters per second, so it's got kinetic energy at the start, and it also has gravitational potential energy because it's at a height of 1 meter. Now, because you're throwing it from this height with an initial speed, it's going to hit the ground and it's going to bounce up much higher than what you threw it at. Okay, so that's the gist of this question. So working through this question, calculate the kinetic energy of the ball as it leaves the girl's hand. So kinetic energy is half mv squared. So this is A. So that's half times 0.100, and your v squared, 4 squared is 60. So what you get is you go 0.5 times 0.100 times 16. You get 0.8 joules. So this is the initial kinetic energy. Even though your calculator says 0.8, it's better to write it as 0.80 because everything is to two significant figures. B, what's the gravitational potential energy it loses? Because when something falls down from a height, it's going to lose gravitational potential energy and it's going to gain kinetic energy. So the gravitational potential energy lost is mgh, so your mass hasn't changed. It's 0.100, g is 10, and it's at a height of 1 meter. So if you put those numbers in your calculator, you go 0.100 times 10 times 1, and you're going to get just 1 joule. Okay? Okay, then the speed of the ball at the instant it hits the ground is 5.9 meters per second. So this is the speed when it hits the ground over there. The speed over here was 4 meters per second, but because she's throwing it with that, it's got more speed. So what's the kinetic energy of the ball as it hits the ground? It's again half mv squared. The half is the same. The m is 0.100, but now for your v squared, you've got to use 5.9 squared. And so what you get is you go 0.5 times 0.100 times 5.9 squared, and you get 1.74 joules. So you're getting 1.74 joules. Okay? Then, how much energy is lost as heat while the ball was dropping? So initially, it had 0.8 joules of kinetic energy and 1 joule of gravitational potential energy. You add both these together, you get 1.8, but it only gets 1.74 kinetic energy by the time it hits the ground. So on the way down, it's lost some energy in the form of heat and sound. So energy lost as heat is total initial energy minus whatever kinetic energy it had in the end, your final kinetic energy. Your total kinetic energy is 0.8 plus 1.0. This is your initial energy minus 1.74. So this is 1.80 minus 1.74. You get 0.06 joules. So that's the amount of energy that's been lost as heat. Okay, on its way down. Okay, so what do we have to do now? So that's that. After it has bounced, the ball rises to 1.5 meters above the ground. So how much gravitational potential energy does it gain as it rises? So gravitational potential energy gained is mgh, and your mgh is 0.100 times g, and your h is 1.5. So what do you get? It's 1.5. So I'll tell you how you get that. 0.100 times 10 times 1.5, and you get 1.5 joules. So you're getting 1.5 joules. Okay? So that's as much as it gains. Okay. Then, where am I? Here we go. How much energy is lost as heat and sound during the time the ball is in contact with the ground and rising up in the air? So when it was in contact with the ground, it had 1.74 joules of energy, and when it rises up in the air, it's only got 1.5 joules of energy. Okay, so energy lost while rising up in the air is 1.74 minus 1.50. You get 0.24 joules of energy, and that's the amount that's been lost while it's rising up again. So total energy here is greater than the total energy there, so you just subtract that and you get how much energy was lost when it goes back up again. And I hope that made sense. Bye for now.